water. It's a lifeblood of the Ozarks. Clear, gurgling springs, tumbling streams, and majestic bluff-lined rivers. It keeps this lush, densely green and unspoiled region alive with wildlife. Two free-flowing rivers, the Current and Jack's Fork, are preserved within the Ozark National Scenic Riverways, a national park which attracts thousands to South Central Missouri each year. But this area's biggest asset, the clear, abundant water, is a bit mysterious and often misunderstood. What is the source of the cold, crystalline springs? Why are so many caves and sinkholes nearby? The answers lie deep underground, and they revolve around one word: karst. Karst refers to a limestone or dolomite region characterized by caves, springs, losing streams, and sinkholes. Often these parts are interconnected, creating a classic karst system. The Ozarks is full of karst landscapes. Why? The geology here offers a perfect setup for the formation of caves and springs. Eons ago, the area was covered with a warm, shallow sea teeming with life. As sea creatures died, their shells settled to the bottom, forming calcium-rich sediments that solidified into limestone, which then was infused with magnesium, turning much of the limestone into dolomite. Later, magma from deep in the Earth's crust lifted this prehistoric seabed, creating the Ozark Dome. Over time, rainwater falling on the Ozark Dome gradually dissolved bits of this layered rock, carving many streams and rivers. Rainwater flowed downhill, away from the dome's high spots, causing the area's rivers to radiate away from its center. The center line marks a major division between the Missouri River and the White River, both of which have huge watersheds. All rainwater that hits the ground has to drain somewhere. A watershed is an area of land in which all surface water drains into a common waterway. Watersheds interconnect. Smaller watersheds, like those shown here in south central Missouri, drain into larger watersheds. Rainwater didn't just erode the land's surface to make rivers. Underground, the ancient layered dolomite rock was also dissolved. Little holes formed, which grew as the water trickled through and created networks of pipe-like channels. Some became tunnels, which turned into caves. The Ozarks has one of the heaviest concentration of caves in the U.S. In karst areas, many creek bottoms do not have a solid bedrock base and are instead underlaid with fractured rock laced with channels that run into the subsurface water system. These creeks won't hold water. They're dry, except during heavy rainy spells, and are called losing streams. South central Missouri is full of losing streams, like the ones shown in brown on this map of the 11-Point River watershed. Rainwater continues to dissolve this rock, making underground holes bigger, and sometimes the ground above gives way, causing a sinkhole. Sinkholes come in all shapes and sizes. Some are like bowls, others are deep and funnel-shaped, and some are gentle depressions. Many will hold water after a big rain. A few become permanent ponds. Sunken areas can be huge, covering many acres. These are called sink basins. As gravity carries groundwater downhill through these water-carved pipes and tunnels, sometimes the watercourse intersects with an opening in a hillside. Then the flow emerges onto the surface and becomes a spring. One of the biggest single outlet springs in the U.S. is right in the heart of the Ozarks. Big Spring doubles the volume of the Current River. Second largest in the area is Greer Spring on the 11-Point River. And third is Mammoth Spring, source of Arkansas's Spring River. About 6 miles northwest of Mammoth Spring is Grand Gulf, a magnificent mile-long sinkhole which formed when a cave roof collapsed. Now a state park, it features deep, steep passages, a natural bridge, and a large cave that used to lead to an underground river before the cave was sealed up with mud from storms during the 1920s.
I graduated from West Plains High School in 1968. As I was growing up, the old-timers in this area told me many stories about Grand Gulf and how they used to go back to a running river or lake of water in it, throw things like bales of hay in, and they would come up at Mammoth Springs. As I prepared to do my senior science fair project, I contacted geologists in Rolla, Missouri, and asked them how I might seek to prove that that was true. They told me I could put fluorescein dye in the mouth of the cave when water was running into it to see if the dye did come from Grand Gulf to Mammoth Springs. I waited for a large rain. I went down to Grand Gulf one night in the dark, put the fluorescein dye in, then drove about 6 miles to Mammoth Springs, put the charcoal filters in where the water runs over the dam there. We found that it took about 2.5 to 3 days, and the dye did in fact appear in Mammoth Springs. I won a chance to go to a national symposium with NASA, and I presented my results there.
Tony Ade didn't just win a science award, he made history. By conducting one of the Ozarks' first dye traces, he proved that an underground river connects Grand Gulf and Mammoth Spring. Grand Gulf is the ending point for an enormous sink basin that extends for thousands of acres. That sink basin even has a developed surface stream within it. But that stream goes underground at Grand Gulf, which can be full to the brim during heavy rainy spells. Only a few years after Tony Ade did his high school dye trace, the U.S. Forest Service hired Tom Ailey to conduct dye traces.
Our longest distance trace was 39.5 miles, with the dye coming out at Big Spring on the Current River, going in the ground in the 11-Point River Basin.
That trace, first done by Ailey in 1972, is one of the longest distance dye traces known.
This is one of our dye samplers. This is a charcoal packet. It's placed to adsorb the tracer dye. We have left this packet in here since before we introduce the dye. Then we'll take it to the lab and do an analysis. So basically the way these traces are done, you put the dye in, you sample many springs throughout an area, you find out where it doesn't go and where it does go. What we are doing is delineating the area that contributes water to a particular spring. And that contributing area is called the recharge area.
In this way, hydrologists have mapped recharge areas for Big Spring, Mammoth Spring, Greer Spring, and others. Dye traces take away some of Karst's mystery, revealing not only the source of our underground water supplies, but also demonstrating how easy it is to pollute these seemingly crystal clear springs. Ozark soils are thin-layered in many areas, with the underground fractured rock very close to the surface. Even rainwater which seeps through the soil often does not get well filtered, and rainwater that flows underground through a losing stream or sinkhole might get no filtering at all. In times past, sinkholes were often used as dumps, receiving everything from common household waste to tires, refrigerators, oil cans, pesticide containers, and even dead livestock.
Well, there was a dump at Dora, Missouri. We wanted to know where that water went. That was a long time ago, and at that time, People were dumping lots of trash in that sinkhole, and they were even dumping septic tank sludge, pumping from the septic tanks. We introduced dye in that sinkhole dump and recovered it at Hodgson Mill Spring. And the newspaper in West Plains published a big story on the dye tracing, and that was just very effective. When we demonstrated where the water went and the contaminants were not getting cleaned up in transit, then people quit dumping in the sinkhole.
That sinkhole stayed nearly trash-free for over 30 years, but in 2009, it was again littered with recently dumped tires and household trash. Ailey's dye trace clearly showed the connection between dumping in a sinkhole and polluted groundwater resurfacing at a popular spring. But sometimes land management can lead to underground destruction that is harder to prove, or might even go unnoticed unless someone is watching very carefully. Tom and wife Kathy own Tumbling Creek Cave in Taney County. They study everything in the cave: thousands of bats, water chemistry in the cave stream, and its many species of blind cave creatures.
The snail we have here is called the Tumbling Creek cave snail. It's found only in this cave, nowhere else in the world. In the mid-1970s, we had about 15,000 of them here. Now we are down to about 150. That's only 1% of what used to be here. We believe the reason for the decline in the population has been sediment from eroding pasture land, flowing into the cave through losing streams.
To stop the erosion, the Aileys did a lot of work in the cave stream's recharge area, filling gullies and replanting stream banks.
Now the sediment is reduced. We are hopeful that the snail population will come back up.
In caves throughout the Ozarks, other species are also threatened, including the Ozark cavefish, grotto salamander, pink planarian, and bristly cave crayfish, all victim to polluted water in their caves. Improving practices above ground could keep water below ground fit for cave creatures to survive.
This is a losing stream valley that contributes water to our cave. What we've done here is basically maintain good vegetation in the stream channel and adjacent to it. We've fenced livestock out of this area so they're not tramping down the banks and depositing various things in the stream channel. You can do simple things like that and really make a great difference in the quality of not just surface water, but groundwater quality as well.
If you live here in the Ozarks, you're not getting your water out of a big reservoir. Your water comes out of the ground, out of a well. And so essentially what you're drinking is spring water, just pulled right out of the spring water system. Because the land is essentially a three-dimensional sponge, we do have to be very careful about what happens on the surface. Any kind of pollution, anything that's spilled, can very easily end up going through the ground, ending up into our wells.
Non-point source pollution is water pollution generated over a wide area from uncontrolled sources that cannot be traced back to a single outlet. Faulty septic systems are a perfect example. A 2006 study by the Howell County Health Department showed 43% of all wells tested in the county contained pollution from harmful bacteria.
Our study indicates that many of the wells that were found contaminated were likely the result of malfunctioning septic systems.
In karst areas, wells and septic systems should be carefully installed, and septic tanks should be pumped regularly to protect against pollution. Other types of non-point source pollution that put groundwater at risk include livestock waste, erosion, farm chemicals, road runoff, and just plain trash dumping. Underground water supplies thousands of Ozark households with well water for drinking. It trickles and gushes out of hundreds of springs to feed clear rivers. and it provides enjoyment for countless visitors. The source of Ozark spring water is no longer mysterious. It is simply rainwater, traveling down through losing streams and sinkholes, then flowing within fractured rock and caves until it emerges as a sparkling spring. But these springs, and all groundwater in Ozark karst areas, are very vulnerable to non-point source pollution because thin soils do little to filter contaminants. This creates special challenges to protect drinking water. Water, the lifeblood of the Ozarks, cold and clear, pulses through underground veins of rock in a geologic body known as karst. Human actions can play a big part in whether that lifeblood flows pure and whether it continues to sustain all Ozark inhabitants.
Oh, won't you take care of our springs and our rivers? Let them flow clear, let them flow free. The filth from our sewers, our feedlots, our dump grounds flows from the springs and slides to the sea. Clear, cold, but not pure. There's one thing that's for sure. Ozark springs are beautiful things, clear, cold, but not pure. Too much of the ground won't filter the water. Whatever goes down is gonna come up. We must cleanse our waters up here on the surface. Whatever goes down is gonna come up. Clear, cold, but not pure. There's one thing that's for sure. Ozark springs are beautiful things, clear, cold, but not pure. We still have the time to make a beginning. They did it at Dora and Winona too. We can take care of our springs and our rivers, but it takes all our neighbors, me and you. Clear, cold, but not pure. There's one thing that's for sure. Ozark springs are beautiful things, clear, cold, but not pure.